Yeah, magic. Okay, cool. Hello everyone. My name's Joe. I work at Portworx, technical architect across the EMEA region, which means that I travel a lot. Prior to this I was at Docker, and prior to that I was at Chef, so I've been doing DevOps and stuff as code for a while. I'm going to talk a bit about data orchestration for Kubernetes, but not specifically about Portworx, which is the company I work for. I mean, I will mention them, obviously, they pay for my train ticket. But I'm going to talk in sort of general terms around the success patterns that we see in our customers relating to managing application data. So, you've already heard from Stephen, Lee said this as well. It's pretty hard to argue with this point, right? The industry that we work in, the IT industry, in fact every industry I would argue, is being fundamentally changed by containerization. And there's clearly a maturity curve associated with this, but every organization, whether it's just developers writing web applications or whether it's major banks running 30 production clusters, are using containerization in some way. Now, I've been caught out, I shouldn't have, okay. So there's an interesting survey by Aqua Security, and they asked this question, right? Do you use containers in your organization? And I think that's pretty exciting. 87% say yes. That's amazing, especially considering where we were a couple of years ago. The speed of adoption is so great. The other thing is, look at the production answer. 90% of people in production with containers right now. And again, going back 2 years ago, that would have been, what, 20%? Probably, something like that. I think the other interesting thing is who is doing this. Now, generally what we tend to see is that managed service providers and technology companies are some of the first to adopt these changes. MSPs, because their customers want it. Right? They're saying, hey, we heard about this cool new thing, we want to buy this from you, please build it. But what's interesting is that typically risk-averse organizations, especially in the finance sector, are going big on containers. And I think this is showing a fundamental shift in all industries. If you look at challenger banks, for example, they're doing well because they have no technical debt, right? They can move fast. So I think finance organizations understand this, which is one of the reasons they're also going big on containers to get some of the benefits that Lee was talking about at the start. Now, why are people doing this, right? Now, this analogy I actually stole from one of my colleagues who travels almost as much as me, but generally, my inside of my bag looks a bit like this. And it kind of reminds me of OpenStack and many other infrastructure environments. I come from a managed IT background and have experience working with, well, I was about to say I can't name them, but they went out of business recently, so Thomas Cook. As an example, we had a really diverse IT landscape, right? And it meant that we were building these kind of really custom infrastructure environments to make these large enterprise applications run. Now, of course, the benefit of this and the benefit of the container is that you have this single pluggable way of running your application on essentially any underlying infrastructure environment. And again, that was something that Stephen was talking about with his multi-cloud and the overlay that Platform 9 provides, right? Now, there's certainly a maturity curve around the adoption of these containers. We all agree that everyone's doing it. We agree with the benefits of that. But I think organizations fit in many places on this curve. And if I think back to my time at Docker, what Docker did a great job of is kind of productizing a load of existing technologies and making them easy to consume and run with a really nice API and a number of helper tools, right? And that drove developer adoption of that technology. But what we see with Platform 9 and other schedulers, the kind of maturity in that space is that it started to spawn pilots in these organizations, right? Docker Swarm, Mesos, Kubernetes now is massively dominant, but those schedulers drove these pilots. And of course, many were successful, which is why we see organizations going into production at the scale that they are. Now, going into production with any technology requires you to look at what I believe are these kind of three critical pillars, which are security, monitoring, and storage. And obviously, Instana plays a big role in the monitoring space. Now, Portworx started off very much on the storage side, and we provided a whole load of services around container native and cloud native storage. But I think what we're seeing, and what I learned yesterday actually at our customer roundtable event, is that this is the next wave of adoption in this space. It's very much Kubernetes becoming the standard deployment target across the entire business, becoming the default. And with that comes a number of additional challenges, such as how do I manage my applications when I have 30 production Kubernetes clusters running across 5 infrastructure environments? Or how do I manage my data when I need to move from one cluster on-prem to another cluster on Amazon? And then how do I manage those clusters themselves? Stephen can answer that one for you. Does this agree with this? So the kind of thing that you're seeing as well? Yeah? I'm only getting a few nods, so just going to make sure. And I think with the change in adoption and the maturity of these platforms, they're also changing personas. So I spent a lot of time talking about DevOps over the years, and the responsibilities here are quite clear, right? We have a clear demarcation point. The operator team or the operations team, their job is to manage infrastructure, right? Storage, networking, cloud, on-prem, it doesn't matter, and get it to a state where the applications will run. Right? That's their fundamental job. The developers, they don't care about any of this. All they want to do is package up their applications, build them, and deliver them in some kind of format, an archive or binary or whatever it happens to be. Right? But what we're seeing with these platforms is that you have this new team, which I think we should call the POP team, because it just kind of sounds cool, right? DevOps, right? It's not going to catch on, don't worry. And their job is to now provide this platform on top of the infrastructure, but none of these people care about each other. That's what I found, right? The platform team, they don't care about the infrastructure, not really. Give me a CPU, some memory, some disk, and a NIC. That's all I care about. It can come from anywhere. And the developers, they don't really care about how the platform works. They just want a Kubernetes endpoint to deploy against, right? So change is good, because what we're seeing is that the infrastructure is increasingly commoditized. And that means we're getting closer and closer to the actual value of the investment we've made in that infrastructure, which is just consuming the resources themselves. That's what we want from the tin that we're buying and investing in. And it also means that developers now can move more rapidly, they can be more agile, you can create deployment catalogs and self-service kind of dashboards where you can just log in and click a button and say, I need a Jenkins, and a Jenkins will pop up. You don't know how, but it happens, and you can move faster, right? And it also means that now, if we have this consistent deployment target, no matter what the infrastructure is, I can run my application anywhere, as long as I'm given access to it. And of course, all the benefits of Kubernetes are built in. So if something breaks, it self-heals, and my application just pops up somewhere else, and I don't need to know about that. The beauty of container orchestration is exactly that Kubernetes lets us deploy our application, and should that worker die, it pops up somewhere else, happy days, no one notices a thing, ideally. But change is also tough, because these platforms, and this is what Stephen was talking about, are hard to build and maintain. It also introduces a set of challenges, because the assumption is that we can run any application here. But the reality in enterprise organizations is that applications need to store data somewhere. And these platforms aren't out of the box designed to handle enterprise needs around data management. And the last thing is that developers don't care about the platform not being able to do that. They want to be able to deploy this sort of stuff. And this is definitely where the industry's going. Anyone use these things? Yeah. Anyone use them in containers? Yep. Excellent, good. What we see a ton of is database as a service inside the business. So I don't want you to be able to deploy databases. I want to run a MySQL cluster, and you just talk to that instance in that cluster. Or just spin up a Jenkins on demand. These are the kind of ways that IT organizations, I see anyway, are changing to provide these on-demand services. But of course, the platform itself needs to be able to actually provide a production-suitable, resilient environment to run these services in, right? And of course, people still have legacy stuff. No one's from IBM, are they? Okay, so DB2, for example, and SQL Server, which still exist in enterprises and still form an important part of those platforms. And when you talk to enterprises about this, they say managing data, managing storage, and having DR options for these parts of the stack is hard. And many say that it's actually blocking their move to these platforms. They know they need to do this. There are many business and financial reasons for doing so, but actually running a data layer that isn't integrated with the scheduler is counterproductive. Right? So how do we solve for data? Well, we already have an awesome way of packaging and delivering applications. Right? You can probably guess what that is. But it turns out we also have an excellent way of packaging and delivering data, which is a container volume. Anyone used container volumes? Yeah. So there is in Docker, you create a Docker volume and put data in it. But there are many types of container volume depending on the service that you're using to provide that. And Kubernetes does an excellent job of orchestrating our containers for us. And something like a Portworx, and there are others, not as good, do excellent jobs, well, in our case, of orchestrating the volumes. So what does that mean? Well, if we now bring data orchestration into this picture, let's say this time we're deploying Postgres. And we have, as part of our deployment, also requested a volume to store our Postgres data in. So in the background, something like Portworx or something else will do things like replicate that data across the cluster. So then, when you hit a failure, to link it back to the original example, a decision needs to be made about where to redeploy that application. Now, if the data layer understands what's happening at the application layer, it can inform the application layer of the best place to put the application, which in this case is obviously on the same machine as the data copy lives, right? So when we talk about data orchestration, this is what we're saying, an understanding, a tight integration between another layer of software running in your stack that is aware of where your data lives and what the application needs to do to access that data. Does that all make sense? Okay. So I already have storage. Why do I need more storage? Well, hopefully you don't have all of those things, because that would be mildly complex to manage. I think when looking at infrastructure, we assume we mean servers, and you need to go back to the fundamental principles that we're building platforms for, right? And the first is that we want to drive everything through that common deployment target, that common API, which is Kubernetes. The second is we don't want to tie into infrastructure, we want to be able to run this anywhere. And the third thing is we want developers to self-service. Those are fundamentally the main reasons that people do this, right? Outside of the business reasons. Well, let's look at the developer-centric side of this. If we're not able to create that abstraction of the storage layer as well, then we end up writing code for infrastructure in Kubernetes. Now, you don't do that for anything else, so why would you do it for storage, right? Everything else that you do related to infrastructure in Kubernetes is declarative and completely disconnected from the infrastructure itself. We should take the same approach with storage, right? Otherwise, a developer is going to be writing some code to talk to local disk, some code to talk to NFS, some code to talk to Amazon volumes, and you end up with the same sprawl we were talking about before. Density is also a massive issue. A common pattern that we see is creating one maybe virtual disk of the MDK or one LUN from a SAN or something like that for each volume that I need for my database. So you end up with hundreds of volumes for your containerized applications, which is fine, but it means you're going to be massively over provisioning. And if you do need to carry out some kind of operation, like a snapshot, for example, it's very difficult to be granular if you try and load lots of volumes in. So you have this kind of disconnect between either massively over provisioning or having massive operational challenges by taking the infrastructure-centric approach. And finally, the option we see lots of people try, and this is where most of the failures occur, is to orchestrate the infrastructure. So I talked about a worker failing and pods getting redeployed, right? So some people try and make the storage follow the pod. So what I mean by that is if the machine dies, you disconnect the storage and try and reconnect it somewhere else to get access to that application data. That breaks regularly and is slow. So if you think about one of the benefits of Kubernetes, we love the fact that pods get redeployed and come back in seconds. But if it takes 5, 10, minutes, maybe an hour. I think the SLA in Amazon is 3 hours. For that volume to reattach, then that's how fast your platform is. So why are you running Kubernetes if you can tolerate 3 hours to reconnect? Right? So it kind of undermines the benefit of the platform that you've built. Okay. Any questions at this point? All right. So let me just sort of wrap up by talking about what people are, well, what others are saying really. We're talking about stem cells, this idea of a common platform architecture that you can repeat. Now, what many organizations, oh, didn't know that was animated. What many organizations are doing is building these internal service providers. I guess you see that as well, right? The idea is, you know, as an internal customer in this business, I can come along and request a environment, and it could be kind of a cookie cutter Kubernetes cluster, right? Now, that's what I mean when I talk about stem cells. What are the patterns that we see leading to success when it comes to stateful services in Kubernetes? Well, there are 3 areas. The first is, how do you manage the data inside a single cluster? And I've already talked about failover and replicating data and making sure your app follows the data and keeping those 2 things in sync. But we also see lots of organizations struggle to tune that underlying storage to meet all the different applications that they could be running. If you have one underlying storage solution and 50 different stateful applications, how do you get that tuning granularity? How do you dynamically change how the storage behaves to meet the needs of the application? So these are some of the things that people need to consider when building these platforms that are going to be hosting stateful services. Obviously, Portworx does that amazingly well. The second is multi-cluster. And this is, not everyone's in this space, but we're seeing it more and more. Particularly having an on-prem environment and a cloud environment. Perhaps you want to do some testing in a temporary cloud Kubernetes cluster, destroy it once you're done, and then move things back on-prem. How can you migrate data with the application between multiple environments? And for some organizations, they could have development offices in China and another one in South America, and they want to be able to say, hey, this is the most recent version of our app with the local test data. We want to lift and migrate all of that over to this target cluster elsewhere. So those capabilities, being able to migrate apps and data as a consistent asset, is really important for those kind of use cases. And equally, and this never goes away, disaster recovery, what if I lose a site? If I have a production cluster getting hit with traffic and there's some databases running in there, how do I recover from that if that site goes down? So these are the fundamental challenges that we see around multi-cluster. Once again, Portworx does a very good job there. And finally, security is a big one. We see a lot of people fall down here where they do an amazing job of building this great production cluster. Everyone's excited. They're on the road to actually launching this new application, and then the CISO gets involved, and they haven't gone through all of the security auditing, and this is where they hit a blocker. So one of the things that we advise is for our customers is to start with security and work backwards from there. And in particular, how do you enforce encryption at the storage layer? How do you self-service encryption for developers? How do you integrate with your existing security systems? Really critical, because if you start to introduce new things, the project balloons very rapidly. And finally, how do you introduce a monitoring and alerting layer to keep track of everything that's going on? So organizations that are addressing these problems of the security space tend to do well when trying to get into production on time. So the final point I will make is the success criteria we see, the fundamental, most important point, is to treat your application and your application data as a single asset, not to approach them as separate things. And by doing that, and using the existing units of encapsulation that exist, the container and the container volume, we see many organizations be successful addressing the application needs in this way. So I will pause and see if I have any questions about any of that.
So this is working with persistent volume claims in Kubernetes.
Yes, that's right. Anyone really doing much with PVCs and storage classes?
Yes.
Yeah, you guys would be, yeah. Yeah, it's definitely a maturity thing, that's for sure. But I think the hurdle of containers as stateless has definitely been cleared. And I was talking to a bank who are based in Canary Wharf yesterday, one of our customers. We currently have 27 production clusters where they're running 60,000 stateful applications and 20,000 stateless every day. So it's, yeah, and you can imagine the problems that they have related to backups and snapshots and encryptions and all of those things that we're already struggling with virtual machines, but now they're doing it at massive scale in the container space. And this is where something like a Portworx that gives you that orchestration layer really helps them out. Any other questions? Yeah.
Potentially a really stupid question, to be honest, because I don't know much about this kind of thing.
Yeah.
But where do people find they're running this kind of thing? Is this a private cloud thing on-prem, or is this sort of containers in it? Presumably not that.
I think as more organisations are actually properly in production, with kind of critical, like core banking applications on-prem. So I see a lot of OpenShift and ICP and those kind of traditional vendor solutions, because they're on-prem deployments, right? And they want that kind of vendor-backed solution. But that doesn't mean they're not doing public cloud. We see a lot of public cloud, but that would be more kind of like the development team want to spin something up, do some testing. But the actual like core banking apps that are containerized would normally be on-prem.
That's good.
And we see architectures where you might have 3 data centers, one big Kubernetes stretched across it. And you can lose an entire data center, and all the pods will pop up over here in a few seconds. And that is like, 5 years ago, that was like a utopian dream, right? And now there are banks in production doing that. And we'll sit under that and do the data placement around that as well. And they're the kind of models that I see now. All right?
No more questions? I think it'd be a good point to have a quick pump-up break then, because we're about halfway through things. So if you need the toilets, are just between the gap on the way out, on the left-hand side. And if we can be back in about 10 minutes at the latest, so about 25 to, and then we'll kick off with the next presentation, which is actually go through and start there, how you can monitor and manage your infrastructure.